There has been, and I actually don't know the origin of it, but various forms of libzfs APIs. I believe the Python folks and middleware folks are to be thanked for that. And from the calls, the broad question is, can we have a committed interface? And we are not aware of, say, would new feature flags greatly complicate any stable interface? And the narrative is that the libzfs.py API is a handshake agreement. It will be relatively well supported, but as users, we do not know those answers and will not speculate. And there's a question of how can we securely retrieve user properties insofar as an unprivileged user can do a ZFS list, and it's a bit orthogonal, but if it lists every user's personal home directory, that's a bit concerning. And then any overlap with channel programs. And just open notes from the discussion. Essentially, we want a C library string up to a certain size. And Jan, do stick around. I'm sure you have some thoughts. And with that API, as we are, and we'll touch on this later, getting things like JSON output on the zpool command, having that API would be invaluable for the mechanical reading and writing of all things ZFS. Potentially an idempotent storage description language. We want this desired state, and perhaps an API would get us there with a nice short path. I believe Python has been the most supported language with regard to libzfs, but there are lots of fashionable languages out there, be it Elixir, be it Go, be it Rust, be it Zig, you name it. And we will not speculate as to what language stability would require for maintenance. It's above our pay grade. Naturally, the documentation, where should one turn to? And let's see, from Rob, he did confirm that libzfs is using programs should call zpool log history to add stuff to the log. As far as I can tell, BEC2. Okay, so that's from yesterday's auditing talk. We found a number of points where the ring buffer for the zpool history might drop things you desire. It might have too much information. Check out the recording. And naturally, in the big, broader picture, we would love to convey wishes and desires. So, from the call, I see a hand from Alan. Let her rip.
Yeah, I know recently Prakash Surya from Delphix was asking about the fact that the libzfs, like the C API library, got a version bump because of some simple changes, and that was causing complications for external apps that use libzfs, especially that, you know, when upgrading ZFS, you can't assume that Grub, for example, got recompiled to use that newer version of libzfs. And, you know, a lot of questions about, you know, how do we strike the right balance between not needlessly changing the libzfs API and causing fallout for people, while at the same time not having to have a frozen API of, you know, we can only have features we thought of years ago when we created libzfs. And what is the right cadence to be able to update that? You know, right now we tend to make that change when we change versions of ZFS from like 2.2 to 2.3, but it turns out that, you know, when deploying this in production, for some people that's still too complicated to deal with. Or especially people, I think in the case of Delphix, are using, you know, not the latest, but a version from the master branch, which is, you know, doesn't have the same kind of guarantees that we will smoothly go from version X to version Y of the library and so on. And yeah, I don't know if others have experience with dealing with this kind of shared library thing. You know, in FreeBSD, we have less of this issue since the library comes as part of the operating system, and so it's going to change with the versions, and everything's going to be compiled to be compatible with that version. So it kind of all moves in lockstep, so you don't have as many of the complications. Or even, you know, if you use packages on FreeBSD, all of the packages are going to be compiled with the version of libzfs that was in the libzfs package that you installed with the other programs. It's not going to get, you know, a mix of old and new versions that aren't going to work together.
Is TrueNAS a heavy user of a libzfs? That's either internal or upstream?
when the version was recently bumped, we had to rebuild several packages. We have Samba depending on it to access some properties. We have few other things. No, most of things depends on libzfs, so maybe slightly more flexible related to library version. But we have to update 3 or 4 package dependencies and rebuild after the bump. It wasn't difficult for us since we anyway building everything from scratch. But yeah, I can see where for people could be problems. I'm not very much a build person, but on FreeBSD we have symbol versioning. Could something like that be used in ZFS, or it's difficult to be cross-platform? I have no idea how it works.
Yeah, I don't know either, but it does seem like the solution where, a program that was expecting, the version 5 API can still access that while, a program that uses version 6, and they both can use the same library. Although I think with the way we have it right now, we effectively changed the name of the file from libzfs.so.4 to .5, and so the programs just couldn't even find it. But yeah, I do wonder if someone that understands how the symbol versioning in libc and so on in FreeBSD works could apply that.
So number 4, the symbol versioning stuff is standard ELF. It should be supported anywhere that has an ELF toolchain. And the thing you have to keep in mind is that it is literally symbol versioning. If you go and change the size or layout of a data structure, it will not help you unless you explicitly write all of the translation stubs to turn, version 3 to version 4 structures and vice versa. So it is an option, yes, but it's an option that still puts fairly significant restrictions on what developers can change if they want it to actually work.
I know that some things we do export to user space, like NVList, AVL trees, some structures and others. I remember when we had to remove some fields from structures, we left intentionally padding in user space just to not change structure size and not change binary compatibility. I wonder, maybe not always possible, but I think right now in CI we have tracker checks for visible ABIs, so we should be able to detect those.
Exactly. With the Abigail tool that we use, we see anytime any structure changes size, and I think part of that will just be when we see that, instead of just updating the .api definition file to reflect the new size, means we have to, continue to have a version that's the old size and then the new version that's the new size. I don't think we in general try to avoid passing structs and instead use things like NVList where, it can be more flexible as far as what fields exist. And that will save us a lot of the pain you would have in a more traditional C API. But yeah, I think in particular when it's, when we add a new argument to a function, that this symbol versioning would allow us to have the old and the new in a way that wouldn't break grub and so on. And I think that maybe that is a path to pursue to make this a lot less painful for people who are trying to use libzfs, especially things like libzfs that are being used in things that won't have the same release cadence as ZFS itself.
One thing that I encountered looking through this is you've got the libzfs, and then there's the libzfs core stuff, and so my question is always, could some of the stuff that's being handled by libzfs, if it's to the point where we think it's very stable, get moved to core so that those of us who are more on the outside can feel like we can rely on it more?
I see faces in the back like you're creating work for us. So when the time is right, I'd love to hear from the developer table. But We'll first explore. Garrett, you had something?
No, I just said that's why we're here. Is
That's
to
why
create
we're here.
work for-
Yes, yes. Show of hands, consumers of libzfs from an external product. TrueNAS, Alan, just along for the ride. Okay.
I think technically BECTL uses libzfs, but and Rod and I are looking at maybe moving that from FreeBSD to the upstream OpenZFS repo, so it would be available for people using boot environments on Linux as well.
Raising hand.
Hello. You're in. Kick on your video if you like, if you want it.
So one use case for libzfs is that I tried to come up with a command which basically takes a UCL file which specifies how a jail should be assembled from snapshots and persistent data, and found that libzfs core doesn't have all the functionality I want. I looked at BECTL or how to access the private ABI of libzfs, and it's really an annoying long addition to your make file to predefine all the right macros and then pull in from the contrib source here the right headers. It's really annoying what you have to do to access the private ABI. While looking at it, I found that BECTL does not record its history, so the pool history will not contain the clones and renames and so on from BECTL.
That was one that came up.
Problem, but it shows that it is a fragile internal ABI. And what a lot of tools like replication commands, be it Zalta or zrepl need, is they send off lots of ZFS list and get. And the especially annoying corner case are user properties, because as far as I know, this may have changed with JSON output support, but before that, you could not reliably ZFS list the value of a user property because it could contain any field separator, because it was just the value is an unquoted C string. So if you had a new line in there, suddenly you could inject malicious lines, which the parser would have no way of detecting, if you're clever about it at least. So you had to send a ZFS get for any user property value if you wanted to preserve it. But going all the way to the internal API is not reasonable in my opinion. What I was thinking is, would it make sense to, instead of stabilizing the C interface, have the ZFS command include a mode where it's running basically like a CGI process, which you can send ZFS commands and it replies with the responses without the startup costs of forking, opening the devices, sending ioctets every time, runtime linking a dynamic executable for every property you want. Instead, you just send it a line, maybe JSON encoded, maybe not, of the ZFS command. It parses it and it sends you properly quoted so that you can maintain it. That could be just one JSON object per line. That could be something different. The encoding doesn't really matter as long as data transparency is maintained and it's easy to interface with from common languages, so that instead of basically stabilizing the API, you have a stable interface to an API service. Just over, so that you can p-open it. On FreeBSD, p-open has a read-write mode, so it would work. On other systems, you set up a pair of pipes and then run it as a child. Maybe
I think for the user property case,
interface.
For the user property case, that's where I think channel programs make sense, especially like I said, because when you try to do a list, if you're getting it back, just as text without the interpolation that you would get, getting it back as a variable that you can quote yourself and so on, or perform operations on before you output, then you would be able to deal with the fact that, this is an 8 kilobyte string that who knows what's in it. But being able to construct a version of ZFS list that would do what you want safely is definitely where the channel program could help you with that. The kind of fast CGI ideas, I wouldn't have thought of that. That might be interesting. I've mostly wanted something like that for ZDB, where you're having the whole cost of importing the pool to perform, a lookup of object number 7, and then it just tells you the information you want is in object number 14, and then you throw away the pool you just imported and import it again, and now look at object 14. And I think Rich Ercolani has the start of a version of ZDB that looks more like FSDB for UFS, where you start it and then point out a file system, and then you get a prompt where you can run successive commands without the startup cost over and over again. But I think the thing I wanted to comment on earlier that was on Dexter's slides as well is what Jan brought up is the zpool history part. And I feel like all of those commands, like cloning and so on, the history should be created by the kernel side so that no application can do a clone without it creating a history entry. And then maybe there's an API like there is now so that a user space tool could log additional stuff, like BECTL might have an additional comment or something it wants to put in the history that's saying, not just that we switched the bootfs property to this, but that what other context that might be important about it, or something that switched, or that it mounted it to /mnt/.bectl or whatever additional one.
I think that's exactly how it works currently.
But it seems right now when bectl uses libzfs to do stuff, it doesn't end up in zpool history at all.
It should. I mean, the kernel logs it.
Yes.
The kernel logs it. If you do zpool history -I for all the internal events, all those are generated by the kernel, and it should have like logging anything that changes state should be logged by the kernel in the internal history, and then the command line tools like the ZFS command or whatever, they can also log things which are not guaranteed to be present, right? Because it's like the system could crash in between and whatnot.
Right.
But that's more like for ease of use. But then all the internal commands describing the state changes should be there.
I guess kernel cannot, by definition, cannot log command exactly as it was written in user space, just simply because it's already parsed and processed as NVList or whatever.
It isn't logging like what you typed on the command line. It's just logging like, I created this data set with this name and this data set.
Yeah,
ID.
but for most users, most convenient is original of zpool create whatever command. And problems with libzfs, it doesn't receive that command. It tries to fake it sometimes, not always successfully, but that's what most people see. Like it's science -I is not default. You may see nothing by default.
Yeah.
I have a quick comment from Stu, who couldn't make it today but will be here tomorrow. Perhaps as an interim crutch, you could pass an output version expected defaulting to the old, if that makes sense. And I do recall moments where with FreeNAS Corral, I tried zpool history and there's silence and it wasn't yet implemented in the API, and I thought, uh-oh. And -I is something that I'm not hearing users being very aware of, and yes, that's on all of us, but
definitely not very advertised. I haven't used it myself much, but in Corral there was approach just to implement everything from scratch and by hand and in Python. But to be fair, executing for everything for command line is quite expensive operation, just to fork exec everything. So when it's possible and it's in performance critical things, we do try to use libzfs directly or PyLibzfs directly from middleware to not fork exec, even so it creates potential regularly compatibility issues and other things. So it's a delicate balance to use command line for compatibility while PyLibzfs for performance, and it's a difficult dance.
Going back to the zpool or ZFS command should log things in zpool history. It really depends on how that's registered. And I was just noticing there is looks like a FreeBSD next boot ioctl that gets registered that does not enable logging. So when you register that ioctl, you can determine whether you want logs to actually happen when that is called. and it looks like that one is set to false. So that may be why, if that's the ioctl that's being used.
Looking at a live example now, I guess the clone that happened when you run the bectl command only shows up in zpool history if you do the -i flag, and I think that's where some of the questions are coming from. Although the boot environment one is a good point, because I do see that the get bootenv is logged, but set bootenv is not, which seems almost like it should be the other way around.
Patrick, mic one.
I wanted to bring up kind of one thing that's like a step further, above and beyond just the libzfs stuff, the libzpool stuff, because I know a lot of, at least some of the things I've dealt with some of the Proxmox Linux side stuff, has an absolutely horrific time dealing with rebuilding, with recreating damaged pools. And so I know I want to be able to give me tools to have a easier to use UI to be able to do that for some of my users.
Anything else regarding a stable libzfs API?
Can you go back to your slide of questions? Because we didn't necessarily
I would love to.
go over all of them. So the first question, committed libzfs interface. The traditional answer has been, you can have libzfs core. I don't really have any comment on stabilizing the whole of libzfs. But the second one, I didn't really understand. What do you mean by feature flags isolate core functionality?
In establishing API, would it make life easier that feature flags are perhaps maybe not supported, and certain things handled there are just not part of the core stable API? It was a naive question from an open discussion, but do feature flags greatly complicate stabilizing an API, or do they make it easier, broadly?
It's more functionality that you would need to stabilize, but I don't think that's the hard part.
Nope.
Feature flags are more recently done, and they're kind of simpler in terms of turning them on and off. Then the next question is about zpool support, stabilizing the zpool stuff that's in libzfs. Is that what the question's about?
Andrew, do you have an example?
Basically just the question that I was just asking, where, if I have to replace a disk, those are those are zpool type commands that I assume use libzpool, because they don't appear as far as I could tell.
No, libzpool is a totally different thing.
Yeah.
They use libzfs, but there's definitely a lot of stuff, like the zpool handling in libzfs is definitely some of the most janky parts of it.
There's no core stable zpool.
Yeah.
So libzfs core is only from ZFS files.
Mm-hmm.
Yeah.
So I guess what I was getting at, because that was definitely me, would be that some kind of stabilization for some of the most basic stuff that as an admin we deal with fairly regularly, like being able to replace a disk and that kind of thing.
Got it. Yes.
And even creating a pool.
So this is kind of getting to prioritizing the things that you want committed, not just hey, can you commit to all of libzfs, but these are the specific things that are kind of most urgently needed, like replacing a disk and stuff like that.
I was just going to say, like, kind of between the zpool support and also maybe committing to certain interfaces. I mean, some interfaces probably haven't changed since we first published them, right? Like, so maybe there is kind of a process that allows them to go into more of a committed state, or somebody can start looking at those and saying, okay, we can commit a portion of that and start building out more stable interfaces. OpenZFS has been around for long enough that we can probably start looking at that. When it was first put out there, we were very hesitant just because there was so much development that was happening. So that was kind of why you haven't really seen much of this. And Matt, I think you were the one that actually started libzfs core, and a lot of that was based on new functionality that was added. So it was like at the time when that new functionality was being built, it was like, okay, we're going to make this portion of it, stable.
We didn't get to retroactively adding everything.
Right, exactly. And I think that, and you mentioned this too, like a little bit about like pool recovery and dealing with like broken pools. That might be, and maybe broken pools in your comment was about like adding devices, and that is libzfs. But if it is broken pools where it's like really broken, that's where like libzpool comes in. And that is, in case that, I didn't know if that was part of your.
Totally broken pools are not something that I'm necessarily concerned with. It's like, okay, I will go to the tools that exist for that, but just things like, oh, I've got a disk that failed out that I have to replace it, or even creating a pool initially, possibly that kind of thing would be stuff that I would really like to be able to present a UI to handle.
Yeah, and I think so. That goes kind of to like libzfs, and are there things that we want in there to stabilize that deal with specifically with zpool operations? There's something on that.
Sounds like Jan had something.
Comment from the internet. One of the operations I found lacking in libzfs core is there's no function to mount a data set.
Yeah, I mean, libzfs core is really made as like a thin wrapper around the ZFS ioctls, and so that's why it works better for some things than others. But there's already existing stable APIs for mounting stuff, right? Like you can just use the mount syscall. So that's probably not like a huge piece of missing functionality, but certainly there are other like complicated compound operations, which libzfs core was really never intended to do. But maybe we still do want to stabilize some API for them, from libzfs.
So the use case I'm looking is jail runtimes, and I would like to have an interface where I can programmatically mount a data set, because otherwise jail startup fails if the jail is already there, because the support for mounting file systems in jails is not very clever about idempotency. Instead, it assumes that nothing is mounted and then runs it, instead of using the auto-mounting logic in the mount command for an FS stop or something. So you kind of have to unmount everything under the jail to reliably restart a jail and then mount it again. And right now I'm doing it through ZFS list filtered, and then ZFS mount evoked once per data set. But all of this loop over stuff and run a ZFS command for every line adds up when you do it in your jail startup path.
Yeah,
so right now I can keep the startup time to less than half a second, but I would like to keep it under 100 milliseconds.
Yeah, that makes sense.
Using just custom crazy shell scripting. But the shell scripting part is not the real time consumption, because it's not the shell which takes the time, it's all the command the shell is waiting for. I trace it out. And there's just certain commands which show up again and again every time. Each invocation is not very slow. It's totally reasonable runtime, but having to start one child process per whatever I'm looping over, that's a part which gets slow. And which shouldn't be necessary if there was a better API to do it, because when you look at it and do it through quick and dirty C code using the APIs of libzfs, it is a lot faster. It's just all of this startup overhead which hurts.
Yeah, that makes sense. I had another comment about your next item, the securely retrieved user properties. And then the example that you gave, I think, was about restricting who can list what file systems exist.
Who can or what they see. I don't
Yeah.
know if it could, how fine-grained that could get, but seeing everyone's home directory listed as marked maybe, it's like, oh,
Yeah.
there's someone on the system and they may have something I'm interested in.
So for that specifically, like restricting who can see what data sets there are, you could use the like zones/jails, code, right? Because like there's existing code that allows you to say like, in a zone or jail, you can only see these specific file systems. And so you could either, use that directly as your security mechanism, or like if you need to do that in some other way, you could probably like take advantage of that code to say, if I'm not root, but I'm this user, then I'm only allowed to see these certain things, and use that same code that exists for the zones, jails stuff.
So we mentioned yesterday, I forget whether it was recorded or if it was just offline, that maybe, this is not a Linux compatible solution, but there's a potential for using like the mandatory access control framework for inserting arbitrary security checks into some of these things, where we actually do have them for sort of regular APIs, but because the ZFS code is this big cross-platform thing, it's maybe not necessarily clear where you could insert that.
Having basically a callback when you're doing ZFS list where it can call something like Mac to say, and is this user allowed to see this one and this one and this one, and basically be able to filter to what they do. But again, that would probably be based on, like Matt was saying, the code that we use. So when you delegate a data set to a jail, when you're inside the jail and you do ZFS list, all you see is that and its children plus the direct descendants to get you back to the root of the pool. But you can't see, the data sets that belong to other unrelated jails. And that could make sense. I think the other part about securely retrieving user properties was, I think, the fact that a user property could contain a new line, and if you try to get that with just ZFS list, then it could, make it look like some other data sets exist that don't really exist, or, you could trick the program that's trying to interpret the text output of ZFS list into doing whatever you want, basically. I know in the past, if you set the share NFS property on a data set, if you could put a new line in there, you could actually share 2 data sets or more and make it do whatever you wanted, which was not necessarily intentional.
At least for user properties, you can securely retrieve them with channel programs. Like you can retrieve, exactly the string, including the new lines and whatnot, using a channel program. But for sure, there's a lot of other things where you would need to use some sort of library interface to make sure that you're getting it securely. But we could add stuff. I mean, we could certainly add things to the CLI to say like, retrieve it with JSON or retrieve it with certain escaping to escape those characters that might be dangerously interpreted.
As far as the share NFS stuff, is that specific to how FreeBSD handles it, or does that seem to be similar across some of the other OSs as well?
So the share NFS one was specific to FreeBSD just because it basically took whatever you put in the share NFS property and wrote it into etc ZFS exports.
Okay.
I know George and Don did a bunch of work to improve how that works on Linux. I'm not familiar with exactly what it is, but I think they commonized some of that.
Because I know I use that field on the Illumos side of things, but I've never tried.
That uses libshare on Illumos, I think, and has a
right.
much nicer way to do it.
But I've never tried to feed it something to break something.
Yeah, well, I think on Illumos it uses libshare and has a nice interface, whereas on FreeBSD it was write it to a text file.
Okay.
Now it is better because of work that Don and George did to improve it. Yeah, it still just writes to a text file, but it does it in a better way, I think. In particular, the problem on Linux was if you deleted a data set and it didn't remove the line from the exports file, the NFS server on Linux would fail to start. On FreeBSD, it would just tell you, hey, you have some invalid lines in your config, but on Linux, it would fail to start. And so if you exported a pool, it didn't remove all the lines, and then your NFS server wouldn't start.
That would be unfortunate.
I have another comment from Stu. Perhaps have a multi-tenancy property flag at the pool level.
What would that do?
We'll have to wait for that
Okay.
answer. When he goes to his motorhome from
Yeah.
YouTube while on the road.
So, I did a bunch of the work for multi-tenancy on Linux to give it similar capabilities that you have on FreeBSD with jails, where you can delegate a data set, and made that work on Linux with LXD containers, so that you could, for example, run Docker inside a container, and it would have access to one part of your ZFS pool, but not the whole thing. So Docker could, ZFS create and do stuff, all while being inside there and getting all the username mapping stuff to work, so that the user that owns the file in the container doesn't accidentally leak that privilege to someone else, or vice versa. If they somehow get access to, if a real user on the host system creates a file in that data set, the people inside the container wouldn't be able to access it, even if they happen to have what looks like the same user ID.
I think we may have a follow-up shortly.
Yeah, restrict default zpool list views.
But how would you, I could see a property that just meant you can't run ZFS list unless you've been ZFS allowed to see ZFS list of a certain data set. By default right now, everybody can just run ZFS list, and maybe an option to lock that down would make sense, but I don't know, a property would be a good way to try to control who can see what.
Yeah, I wonder if if the concept of having a data set owner or data set group or something like that you validate. So if you assign let's say a group to a set of file systems, then if you're in that group, they get displayed. If you're not in that group, they don't get displayed. Something of that nature. Maybe that's what people are interested in or looking for.
And it seems like something you could extend the existing ZFS allow framework to do. And so you would just need a property that changes the default away from everybody can list all the data sets. And then once it's set, you have to use ZFS allow to say these users or these groups are allowed to list this subset of data sets, using the mechanism we already have that control whether they can create snapshots on those data sets or destroy them in every other command. I just think ZFS allow just doesn't have list as an option right now, and we've never decided that visibility was something they might need, but maybe it is something that makes sense, especially in a multi-tenant environment.
And you reminded of something yesterday to be vocalized, which was allowing destroy allows a user to perhaps destroy a snapshot.
The vice versa, yes. It would be nice to extend ZFS allow to have a permission that only lets you destroy a snapshot, but not a data set.
Yes, that would be.
And the other one I would like is being able to ZFS send a raw version of the data set, so you can send the encrypted version, but you can't send the plain version where it's going to decrypt it before it sends it. Because if you're going to have a script that and an SSH key that allows someone to come and take a backup, maybe they shouldn't be able to get the decrypted version.
This is starting to smell like Apollo's apples.
It's kind of
Repeat
separate
that.
applied.
This is starting to smell like Apollo ACLs that basically are very long extended access control lists that allow very fine-grained control over management type operations of any object in the file system.
Yeah, next you're asking to only be allowed to destroy a snapshot when it has reached its mandated replication factor to offsite backups. Like,
Right,
there
or a
has to be
certain
2
age
replicas
threshold
of
and-
this before you get to destroy it.
Or, only can destroy snapshots that match this regex. Right? But it can quickly obviously get out of control, but just a little more granularity there could be nice, because the ZFS allow system is very expressive now, and lets you control which properties the user is allowed to set and so on. But as we've added features, we've not necessarily kept the access control up as well.
What languages beyond Python do we have some notion of a libzfs for all those Rastafarians and Golangers?
I think there might be Lua.
Zigsters?
They'll be in the upstream repo, but I think there's a Lua one. I don't remember.
There's a Lua one? Okay.
I don't remember.
Great.
I think because a bunch of the FreeBSD bootloader and stuff uses Lua, and so it made sense.
My personal opinion is whatever language they tell me I need to use, I will use it even if I don't know how to use it yet.
Anything else on... Oh, we have another question from the feed. Go ahead. Stu says, role-based viability a la sudo was his example, going from the Apollo example to the sudo.
Visibility.
Visibility, thank you very much. Type AutoCarrot.
Right, so I think ZFS allow is the mechanism we have that controls every other similar, like, you control what users have access to every other subcommand of ZFS. So ZFS list being added to that list, I think, makes sense. It's just mostly how do we deal with the fact that by default that one was always allowed, and we're going to possibly make it so that you can decide that it's not.
So currently the way that works for properties, though, is it only affects whether you can set the property,
set
not
the
whether
property,
you
not
can
read it.
see it.
And I think I don't know if there's actually a thing in there to control whether or not they're allowed to set and get user properties. I don't know if there's like a blanket setting that controls whether you can set user properties or if everybody can just set whatever they want. I don't actually know what the rules are for that.